So now let's go ahead and take a look at a case study that will put all the pieces together we've talked about so far. And this is case study ex4. And this will demonstrate how to implement Lambda expressions, and we'll do it in the context of a multi-threaded example that will show how to create a Java thread that will run a Lambda expression and then do some stuff with that thread. And you can find this particular example, which we're about to walk through, in the ex4 project in the FP folder in my modern Java portion of my GitHub repository. So this is the modern Java repository on GitHub. So we're now in my IntelliJ project for case study ex4. And this particular example is going to show various ways to create a Java thread and then pass a runnable Lambda expression to it. And you can see here, it's got a couple of different method calls, a couple ones that are real simple, and then some other ones that demonstrate some examples that check to make sure the results are correct. So let's start by taking a look at the simplest one. This is called thread simple hello world. And what we're going to do is we're going to call a little helper function called start new thread. And that's going to make a new thread with the runnable we pass to it. And it's going to go ahead and start the thread, and then it's going to return the started thread. So that's what start new thread does. We're going to use that in all the different examples here. And you can see what we pass as a parameter is this runnable Lambda, which is going to display hello world. And we'll see what display does. Display is just a simple helper method that prints out the calling thread ID, so you can see what thread called it. After we start a thread, we're then going to print something to the output, and then we're going to block until the thread is done. And join is a very simple example of a so-called barrier synchronizer that will block until the computation is finished. This computation is going to take very little time, so it won't block for very long. So that's one example. Let's take a look at another example. This time, we're going to assign a runnable Lambda to a local variable, just like we showed in the slides. Then we're going to start the new thread passing in that local variable. Once again, we display the results and then block until the thread is done. So pretty much the same thing, just showing you can pass things as variables. Here's an example that demonstrates the use of effectively final variables. Here, answer is an effectively final variable. And we're going to pass in a Lambda expression that reads that effectively final variable, start it in a new thread, say that we're going to block till we're done, block until the thread is done, and then return the answer. That's one way to do things. Here's another example where I'm going to demonstrate what happens if we make an attempt at trying to modify a variable that is defined outside the scope of the Lambda. So you can see here we try to assign answer to 42 inside the Lambda. Not going to work. You can't do that. It has to be treated as an effectively final variable. So that was just there to show you what not to do. And then here's one of the ways you can work around the limitations on having to have effectively final variables for your Lambdas. You can make a one-element array. And then down here, we can assign to the 0th location. We can read from the 0th location. We can return the 0th location after the thread is returned. And this works as long as you don't have race conditions. But it's one way. If you know that you're not going to have race conditions, this can be useful. But if you're not sure if you have race conditions, or you just want to be a little bit more careful, this is the other way to do it. You can make yourself an atomic integer. And then inside the scope of the Lambda expression, you can set the atomic integer, which is now a reference type. So we're not actually modifying answer directly. We're modifying what it references. And then we can set it and get it both here as well as at the end when we're done with the call. So those are a bunch of different examples. Let's go ahead and run this little program. You can see we just click on ex4, and it's going to go ahead and compile everything and start to run it. And you can see that it goes ahead and puts the blocks in where we expect them to, and returns the various answers that we've got based on the different methods we're calling. So just a simple, fun example to demonstrate how Lambda expressions can be used. Obviously, we're going to look at a lot more sophisticated uses of Lambda expressions, but this should be something to get you up and running. If you don't have experience using Lambda expressions, this will show you some of the easy ways to do things, particularly for things like threads that don't take any parameters in the Lambda expressions. We'll look at more sophisticated versions shortly, more sophisticated examples that will demonstrate passing parameters as part of the Lambda expressions.